All right, ladies and gentlemen, in this video, we are going to be continuing our discussion on triangles in a very introductory method. Today, we are going to start working on finding angle measures. And the real purpose of this video is to define what the triangle sum theorem and the exterior angles theorem are and be able to use them to find missing angle measures. So let's get right on into it. The first question I have for you is, see if you can kind of think back to prior to geometry. You know the answer to the question prior to the geometry. It just may have slipped your mind at some point. The question is, the sum of all of the interior angles of a triangle have to add up to what? Hopefully you remember that back in the day you learned that it was 180 degrees. And that, ladies and gentlemen, is what we call our triangle sum theorem. The sum of all of the interior angles of a triangle have to add up to 180 degrees. I cannot stress the importance of this, ladies and gentlemen. It is going to be vital in our remainder of our curriculum and just in kind of your geometry and higher level mathematics focuses, wherever it takes you, you are going to have to know this forever and always. So all the angles of a triangle add up to 180 degrees. That is our triangle sum theorem. Now, we also have a very interesting one known as the exterior angles theorem. The exterior angles theorem. Now, the exterior angle says the exterior angle of a triangle, remember, exterior angle is outside, exterior meaning outside, is equal to the sum of what I call the opposite two opposing interior angles. So angle 1 is equal to A plus B, all right? So angle 1 is equal to A plus B. The interior A and the interior B. Very, very much so. Keep that in mind. So let's take a look here at an example of how we can utilize our exterior angles theorem. So here is an exterior angle. Again, how do I know that? Because it is outside of the triangle. So if that's the case, then my exterior angle, 2x minus 5, has to be equal to the sum of the two opposing interior angles, the sum of the two opposing interior angles. And then it would allow us to set up an algebraic equation such as so. So let's solve for x. Subtract x, you get x minus 5 equals 70, and x equals 75 when I add it on over. It wants to know the value, however, of JKM. So this is our angle we're trying to focus on here, is JKM. Well, what do we have to do? Well, you have a couple options. One, what do you think? I could take x equals 75 and then do what with it? I could substitute it into here, or I could substitute it into here and use what? Well, we could just use what we just thought about with our triangle sum theorem. And because that's the point of this video, let's go ahead and do that. If x is 75, that means this value is 75 as well too. And the remaining angle is whatever 75 and 70 is subtracted from 180. So really, the measure of angle JKM is equal to 180 minus 75 and minus 70. So it's really 180 minus 145. So 180 equals 180 minus 145. 180 minus 140 is 40, and 5 more, of course, gives us 35 degrees. Okay? So there is the use of our triangle sum theorem and a little bit of our exterior angles theorem as well. Let's go into one more theorem that we're going to talk about, and that is the corollary to the triangle sum theorem. So let's recap. What we said before was that the triangle sum theorem stated that all of the interior angles have to add up to 180 degrees. Well, let's think about this for a sec. The corollary tells us, and I'll explain the corollary in a sec, the corollary tells us, well, what if it's already a right triangle? Can we make kind of a common sense conclusion based off of whether it's a right triangle or not? Well, of course we can, because 90 degrees already takes up one of the angles. So what's left over for the other two angles? 90 degrees, right? The only way that this works is that if the two other non-right angles also add up to 90 degrees. And so this will help a lot, kind of save some time. I think this is a time saver theorem more than anything. And just to kind of recap corollary, if we don't quite remember what that term corollary means, a corollary just simply is a statement that can be proved using the original theorem. So this is a very, very simple theorem to prove using the triangle sum theorem. Now, I think, honestly, an easier way to put corollary is kind of a quote-unquote add-on to a theorem. It's kind of an addition. It means the exact same thing, but it takes it just a little bit to that next level.